So we talked about atoms and how atoms are made of protons, neutrons, and electrons, and we talked about elements that are made specifically of a specific number of protons and then neutrons and electrons. Now, the number of protons in any given atom is fixed, okay? It means that it's never going to change. Hydrogen will never have more than one proton, okay? Carbon will never have more than 6. However, the number of neutrons and the number of electrons can actually vary even within an element. So we can have different versions of an element that have different numbers of either neutrons or electrons in it. So here's an example of hydrogen. If we looked at hydrogen on the periodic table, it would look like this. There's one proton, its atomic number is 1, and there's one proton and neutron, so typically that would mean that there are 0 neutrons. Okay, so here is an example of everyday ordinary hydrogen. 1 proton, 0 neutrons. Now, there are also 2 other varieties of hydrogen molecules or hydrogen atoms. Deuterium, which is going to have 1 proton. Again, it has to have 1. It's fixed. That can't vary. But it also has 1 neutron. And then there's this version over here, tritinium, where there's 1 proton, but there's 2 neutrons. All of these are examples of hydrogens. The difference is that there are different numbers of neutrons. These are called isotopes. So an isotope is a variation of an element with the same number of protons and electrons, but has different numbers of neutrons. Now, we talked about the atomic number or the atomic mass last week and how it's actually a decimal in most cases. So honestly, if you looked at the atomic mass of hydrogen, typically it's 1.01. Well, we get the decimal because when we figure out the average, this is the atomic mass, right? So it's how much the atom weight, how much mass it has, right? How much matter is in it. So this is going to have more matter or mass in it because there's 2 neutrons than this one that doesn't have any neutrons, right? So think about it in terms of if we were on Earth, this is going to weigh, this one will weigh more than this one will, right? There's more mass to it. So when we figure out the atomic mass, we take the average of all of the different weights of every different isotope that can exist. So we would take this one, this one, this one, and we would see how often they appear in nature, and then we come up with an average atomic mass, and that's why you get the decimal. Now again, for our purposes, we'll always round up and round down, but just for an FYI, that's where the decimal comes in. Isotopes are really important in medicine because isotopes can give off radiation, so radioactive isotope, and that radiation we use to image things inside of our body. So MRIs, CAT scans, X-rays, all of those are using radioactive forms of different kinds of elements or radioactive isotopes. So we use isotopes a lot in the medical profession. So again, just to review, protons are fixed. The number of protons will never change in an element. However, an element can have different numbers of neutrons in them. And in this case, hydrogen can have 2 neutrons, it can have 1 neutron, or it can have 0 neutrons.